harvesting energy from the sea. Japanese researchers have come up with special technology that can not only capture energy from waves, but also help protect coastlines. A team from Okinawa plans to set up energy harvesting turbines near tetrapods, which are concrete structures placed along the shore to weaken the force of incoming waves and prevent erosion. The turbine has 5 flexible blades modeled after dolphin fins. It's supported by a stem that's anchored to the seafloor with mooring cables, which, like the blades, is flexible and can bend under pressure. Inside the turbine head is a magnet electric generator, which transforms wave energy into electricity. The electricity is sent back to the shore via cables to feed into the grid. Using turbines on just 1% of Japan's coastline can generate roughly 10 gigawatts of energy, equivalent to about 10 nuclear power plants. Apart from tetrapods, the turbines can also harness electricity near coral reefs. They're built to be safe for marine life, with blade speed carefully calibrated so that any animals caught in them can escape unharmed. The team is currently preparing to install 2 half-scale model turbines that will power LEDs as part of a commercial demonstration. Here are more sustainable energy solutions.
Japanese engineer develops turbine that loves typhoons. A new type of wind mechanism being developed in Japan is designed to not only harness power from the wind, but also to be particularly effective during typhoons. A typhoon turbine created by a Japanese engineer consists of 3 vertical blades and a central rod. It has an omnidirectional axis so that it can respond to wind coming from every direction. The turbine makes use of the principle of the Magnus effect. Air curves when passing by a rotating object, and the downward deflection of the airflow produces a lifting force that counteracts the force of gravity, enabling the object to remain airborne. The blades are controlled by the central rod, which can be tightened to slow down or stop the blades completely regardless of the external forces. Under normal circumstances, the typhoon turbine can achieve about 30% efficiency, while a conventional wind turbine can achieve 40%. However, conventional wind turbines can be damaged by typhoons, while the typhoon turbine would still function normally in a large storm. The designer of the typhoon turbine believes a single typhoon would be able to generate enough energy to power Japan for 50 years. According to the Japan Guide, about 7 or 8 typhoons pass over Okinawa Prefecture each year, with about 3 hitting its main islands. If the typhoon turbine is proven to be functional under extreme weather, then Japan could harvest a significant amount of energy to power itself for a long time. Cameroon turns human waste into clean power. 2 towns in Cameroon are installing biogas systems to turn human waste into sustainable energy that can provide fuel and electricity for local communities. Organic material such as animal waste is placed inside an airtight tank where bacteria and archaea break down the material. This releases biogas, which is a byproduct that is a mixture of mostly methane with some carbon dioxide. The biogas can be stored and burned as a fuel for cooking and to power electricity generators, while the rest of the waste can be used as fertilizer. The biogas system installed in Cameroon connects a septic tank to biodigesters, linked to individual households. Human waste placed in the septic tank is converted into biogas by the biodigesters, and this releases energy into people's homes. More than 3,000 households and local schools in 2 towns have reportedly installed the biogas system. It is estimated that the project may reduce greenhouse gas emissions in the vicinity by up to 60%. The project was initiated by Bioenergy Cameroon, a non-governmental youth organization. The group trains local students, especially female students, on how innovative technology like solar power and biogas work. London's street will be able to harvest kinetic energy. A street just off London's West End has been transformed into the world's first smart street. London's Bird Street has been equipped with a stretch of electricity-generating floor tiles and a bench that can filter air. Small energy-storing flywheels are equipped inside the tiles. As footsteps land on the tiles, the weight creates a downward force that spins the flywheel, which then converts kinetic energy into electrical energy through electromagnetic induction. Each tile can convert footsteps into 5 watts of electricity. The electricity can then be used to power street lamps, speakers, and Bluetooth transmitters. The clean air bench at one end of the street, besides providing a resting area for pedestrians, filters gases such as nitrogen dioxide and other particles. It then expels the air that has been cleaned. The same electricity-generating tiles are also installed at Heathrow Airport and at football pitches in Brazil and Nigeria. A new way of getting power from the sun. Researchers in Britain have developed a new type of technology that can help buildings to harvest solar power in addition to the power generated by rooftop solar panels. Solar squared glass blocks contain a layer of small solar cells. The intelligent optics of the blocks focus incoming sunlight onto the solar cells when placed vertically. The blocks can be linked and wired to one another, generating power for buildings and electric vehicles, or to be stored in batteries. These blocks can be embedded in conventional construction designs. Tinting can also be added to prevent too much sunlight from entering the building's interior. Researchers say the blocks also offer better thermal insulation than traditional glass building materials. Startup company Build Solar, which developed this project, is looking for test sites for this technology. A finished product is expected to be available next year. Netherlands set to spend 150 million euros on biogas production. The Netherlands has found a use for their cows other than pumping milk, turning their manure into energy. Manure processing is important to the Netherlands, as about 10% of the country's greenhouse gas emissions come from agriculture, mostly methane from animal manure. The International Dairy Federation says the nation's livestock produces about 74 million tons of manure a year, which is too much to be directly applied to farmland as fertilizer. The excessive amount of nutrients could leak into underground water, resulting in algae growth and pollution to nearby water sources. To solve this problem, officials have implemented an experiment at one farm. Cow manure is put through an anaerobic digester, where exposure to bacteria transforms solid manure into liquid form. The resulting substance then releases biogas that is made mostly of methane and carbon dioxide. The biogas can be used as fuel, while any leftover manure can be used as fertilizer. This experiment reportedly generated 9,342 kilowatt-hours of electricity in 20 days, which is enough to power 3 homes for a year. The Dutch government has committed to investing 150 million euros to the biogas program, which aims to get 1,000 large farms across the country to produce energy from cow manure within 4 years.